Hi, today we are here to introduce a new course called Radio Astronomy in NPTEL for the first time. I'm Virup Datta. I'm a professor in Department of Astronomy, Astrophysics and Space Engineering at IIT Indore. I'm a radio astronomer by profession, and I'm going to explain to you why someone should be interested in taking a course like this on NPTEL. What I show here is the entire electromagnetic spectrum, starting from the very high frequencies on one end to the left to very low frequencies to the right. Reversely, very high, large wavelength to the right to very low, short wavelengths to the left. In between, somewhere, lies this vertical stripes, which constitute the minor fraction the visible light constitutes in this entire electromagnetic spectrum. This is where our only eyes can detect light and sensitive to the electromagnetic radiation. Apart from that, we are not sensitive to any other part of the electromagnetic spectrum. Now, if you go higher in frequency from the visible light, we face gamma rays, X rays, ultraviolet lights, which are thankfully blocked by the Earth's ionosphere and cannot reach the ground. However, if I am an astronomer and I want to observe the universe, I have to observe at different electromagnetic wavelengths. In that case, I have to make a space telescope which can go up and observe these wavelengths, gamma rays, X rays, and ultraviolet, from above the Earth's atmosphere. If I'm looking down from the visible light, we see infrared, and there also we need to create space telescopes to observe them, because most part of that band is actually obstructed by the Earth's atmosphere from reaching the ground. Even for visible light, we have to be cautious and place the telescope above the cloud level so that we get more sensitive optical observations. Coming down to radio, what happens is that most of the radio bands are actually available to be observed from the ground surface. Only if you go very high frequency in radio, you may get bothered by the Earth's water vapor content in atmosphere, the troposphere, similar like the optical telescope. If you go further low in wavelength, Earth's ionosphere cuts off the wavelengths to reach the ground, and so we again have to send something to space to observe at the lower frequencies. The point is that since in astronomy we rely on remote observation of the object, we cannot go near to the objects of interest. So we have to observe at different wavelengths to be able to make a complete information and knowledge about the source of our interest. Now, why radio astronomy is so interesting in the coming decades? Due to the enormous advancement in radio astronomy in the past decade and continuously going, we finally ending up in constructing the world's largest telescope called the Square Kilometer Array, which will be spread across two different countries, across two different continents, Australia and South Africa. The whole radio astronomy community is extremely excited with the prospect of unveiling newer mysteries of the universe across different wavelength bands. This and other telescopes in the radio wavelengths which are being planned makes radio astronomy quite exciting science. In India, we are fortunate to have GMRT, or Giant Meter Wave Radio Telescope, near Pune, about 80 kilometers north of Pune. So, several radio astronomers, scientists, engineers do use this wonderful instrument and keep making new and newer discoveries every day. So, it's an exciting field, and I think People should be excited to take a course like this for the first time being offered in NPTEL. I go a bit more into who can take this particular course. Definitely, an astronomy enthusiast can definitely take up this particular course. It doesn't require much of prerequisite. Students from any branches of engineering and science can take this course. You just need the first year of mathematics and physics for the undergraduate level to be able to understand the nitty-gritties. Programming wise, it's not mandatory to have a programming knowledge, but definitely it is appreciated if you have some preliminary programming skills. How this course is planned? As you know, this is planned across 12 weeks. So more or less each topics over here span for each week. Each week we have 2 lectures and 1 demonstration or tutorial. First module talks about the background. So we review the electromagnetic theory, dynamics. In the first week, we go to teaching radio astronomy fundamentals, about units of intensity, how do you detect radio waves, then black body radiation, and so on and so. We also talk about the major detector in radio, which is the radio antennas, which you have also touched in the basic electrodynamics. If not, we will cover it. Now, as we do these things, we are also giving you tutorials, demonstrations of how antennas radiate or receive signals, and likewise. So there will be a little bit of programming, mostly MCQs, some demonstrations, and some simulations also, which will be exciting. Now, coming to the next module of techniques, we first talk about how a single radio antenna observe. It's possible to observe with a single dish. There are large dishes which were constructed up to 100 meter, 300 meter, and the world's largest is 500 meter telescope in China. After doing the single dish, we come to how multiple antennas can be clubbed to do what is called interferometry in radio, and how the Earth's rotation also helps in that same regard. Slowly, we move towards how we analyze the data. That's very important. And after taking the radio wave, although we say our eye cannot detect radio wave, but we will finally image the sky in the radio, and we'll show you how. So this module will mostly be talking about assignments related to some problems, mostly MCQs, some demonstration, tutorials, and it will be fun. Coming to the third module is the radio astrophysics part. What kind of astrophysics we learn from these radio observations, mostly dealing with continuum radio sky and also some spectral lines, which will be interesting. You're looking forward to some assignments which are mostly numerical and some MCQ. Coming to the last segment of other applications, we first talk about how radio wave propagates through the atmosphere. What are the different propagation effects? This is also important for other branches of engineering and sciences, like how satellite signal communicates and how it transmits. What are the different effects which happens to the signal when it goes through the atmosphere? Similar thing happens for our reception also from radio waves from the cosmos. We will deal with those here. And the last, we talk about very long baseline interferometry. It's quite similar to the Event Horizon Telescope, which detected the first picture of the black hole. Here, we also will introduce other aspects, like for civil engineering, the geodesy is important, and that can be done by VLBI. Lastly, we just summarize the logistics. It will be a 12-week long course. We're looking at more or less 2 lectures per week. and one tutorial session or demonstration. I am the main lecturer, and we have a TA, Mr. Harsha Tati from IIT Indore. I hope this excites you to join for the course, and see you at the class. Thank you.